When we first did our hypothesis test for the mean with large sample, we assumed that the population standard deviation sigma was known. That is almost never the case. So here we're going to assume that sigma is unknown, and we could also have a small sample. So what that necessitates is that we use a different distribution called the student's t distribution instead of the z distribution. Our test requirements for a small sample hypothesis test of the mean are that we need a random sample taken from the target population, and then the population from which the sample is taken is approximately normal. So if you have a small sample, you need normality in your population. If normality fails, then we have to use what are called non-parametric tests. And then our test statistic will change here. We're going to use the t statistic, which is x bar minus mu sub 0, our hypothesized mean, divided by s over square root of n. So we're using s here instead of sigma. And this test statistic follows the t distribution, or the student's t distribution. So that's what changes here. So let's look at an example. So the EPA limit on CO2 emission for passenger cars is 0.95 grams per kilometer. Car manufacturer randomly selects and tests 10 new vehicles. Can the manufacturer conclude that the mean, test of the mean, CO2 emissions for all vehicles of this type meet the EPA standard? So meeting the EPA standard would be less than the 0.95. And we're going to do that at the 0.01 significance level. So here's our data. Those are emissions in grams per kilometer for these 10 new vehicles. So we're going to do a classical hypothesis test instead of p-value. So our requirements are that we need a random sample and approximately normal population. So these were randomly selected vehicles, so that checks out. And then approximately normal population, this we would have to make the assumption, or we could do some normality tests to check that. For right now, we will assume that the population is approximately normal. And that's probably a reasonable assumption. So step one, null alternative hypotheses, H0, HA. So HA, what we're trying to show is that that mean meets the standard. So the limit is 0.95. So you got to be less than 0.95. If that's not the case, then we'll assume that mu is equal to 0.95. Or if you want, greater than equal. And then select our level of significance. That was given to us, 0.01. So alpha is 0.01. And now sketch our rejection region. This is a lower tail test because of the less than. So we will have a rejection region on the left here. And then this t-value, the area to the left right there, is 0.01. And then this t-value has got 0.01 to the left, so if it was t.01, that would be the right area, so we need the negative of t.01. So that t-value then, we're going to use the inverse t distribution instead of inverse norm. And we need to put our left area in there, which is 0.01. And then our degrees of freedom, which is n minus 1. So our sample size here was 10. We had 10 new vehicles, so n was equal to 10. And so our degrees of freedom here is 9. Let's go ahead and enter that into the calculator. So we go to the second variables menu. And let's see, we want inverse t, which is option number 4. Our left area, 0.01. And then our degrees of freedom, 9. So negative 2.82. So that is our critical value. So then if our test statistic is less than negative 2.82, we reject the null hypothesis, otherwise we accept it. So compute our test statistic. So our x bar value, we need to enter the data into the calculator and compute that, and then the same for s. So one variable stats will give us those values. X bar equal and s equal. So I have already entered those into a list. So then I'm going to go to stat and then calc and then one variable stats. And we are using list 1, calculate. So x bar 0.949 and then s 0.03348. So 0.949, 0.03348. Yes. And so now we can compute our test statistic. So we've got that 0.949. We are subtracting off 0.95 is what we're testing against. In the denominator, 0.03348. And divided by square root of 10. So we'll go ahead and compute that in the calculator. So 0.949 minus 0.95 is negative 0.001. We're going to divide that by 0.03348 divided by square root 10. So negative 0.094. So negative 0.09 to 2 decimal places. So our test statistic is about right here. So that is t-test is negative 0.09. And we can see it's not in the rejection region. So step 5 is that t-test is negative 0.09, which is greater than the negative 2.82. So we do not reject. And so state and interpret our conclusion. So there is not sufficient evidence to conclude that the mean is less than 0.95. So the sample mean was less, but it wasn't enough. So we're going to conclude that the mean equals 0.95, our null hypothesis. So these vehicles do not meet the standard. They need to be less than 0.95. They were not. Okay, so new vehicle doesn't meet the standard. So that is a complete hypothesis test using the t-distribution. And then you can check this using the stat functions of the calculator. Go to stat and then tests, and then we want t-test option 2. You want to make sure data is highlighted. 0.95 is our mu0. The list we're using for the data is L1, frequency at 1, and then our alternative hypothesis is a less than. Come down to calculate and enter. And there is our test statistic, negative 0.09, and p-value 0.4634, along with mean and standard deviation. And then if you want to, on the stat functions for the t-test, you can come down and do draw instead of calculate, and that'll just draw the p-value. So there is our distribution. The p-value is the shaded area right there, 0.4634, and there's our test statistic.